Today we're going to look at solving proportions and how to use that when we're doing some problem solving. So here we have two ratios that are put together with an equal sign, two proportions, and to solve that, some people call it the butterfly method. We're going to look at the diagonals and we're going to set up an equation with them. So in the first diagonal there, you'll see that we have an x and 20. So that means 20 times x. We take those two diagonals, we multiply them together, and we set that equal to the other butterfly wing, or the other diagonal, which is 7 times 4. And in doing so, you're going to be able to find the missing value. So first, we want to multiply the sign without the variable. So we still have 20x, and on the right side we have 7 times 4, which is 28. Now we would divide both sides by 20. And when you do that, you will find the value of x to be 28/20ths, which you can simplify. And I have this on my PowerPoint here, so I can do it this way, which is 1 4/10. Okay? Again, we're just going to practice to figure out a missing value when you have two ratios like this. We do the butterfly rings. One side would be 99b, and it doesn't matter if you put that on the right side or the left side. The other side we have 15 times 66. Okay, when we multiply that out, I don't have my calculator handy with me right here. Hopefully this will help me. When you multiply 15 times 66 and divide it by 99, you are going to get 11. Okay, here again this time we have something that looks a little bit differently. On one of the diagonals we have 2d times a -1. On the other diagonal, or butterfly wing, we simply have 3 times 5. So the right side, 3 times 5 is 15. When you multiply 2d times -1, it becomes a -2d. Now you simply divide both sides by -2. And your answer would be -7 1/2 when simplified. Okay, now let's look at, this is where the meat of the material is going to be. Now we see that in our diagonal we actually have an algebraic expression here. So on this side we have 1 times the sum of x plus 10. And on our other diagonal, we have 8 times 12. We know 8 times 12 is 96. Now here, since the number outside of this is 1, when we do the distributive property, it really doesn't change anything, does it? Because 1 times x is still x, and 1 times 10 is 10. But when this number right here is not a 1, you're going to have to evaluate the distributive property first. Now we have a one-step equation, and we would simply subtract 10 on both sides, and your final answer would be 86. Okay, again, we have this algebra, we have an expression right here, so we have, this time, we have 5 times the sum of g plus 3. This time there is not a 1 outside here, there's a 5. So we're actually going to have to do the distributive property, and set that equal to our other diagonal, which is 7 times 5. So 5 times g would be 5g. 5 times 3 would be 15, equal to 7 times 5, which is 35. We have our two-step equation. We subtract 15 from both sides, and that would be 5g is equal to 20. So g in this case would be equal to 4. Do one more example like this. Here's our diagonal. We have 2 times the difference of y and 3, and we're going to set that equal to our second diagonal, which is 6 times 7. Of course, 6 times 7 is 42. Here we do the distributive property, and 2 times y is 2y, and 2 times -3 is -6. Now we have our two-step equation, so we add our 6 on both sides. and we discover that 2y is equal to 48. And then when you divide both sides by 2, y would be equal to 24. Now what I want to do is start looking at what this would look like when we're doing problem solving. Get to the next slide. An architect builds a model of a building before the actual building is built. The model is 8 inches tall and the actual building will be 22 feet tall. The model is 20 inches wide. Find the width of the actual building. So you will see here that we have the model and we have the actual building. So what I'm going to do is I'm going to set up a ratio for the, let's see, we have the height and we have the width. So if we set up, we have 8 inches for the height of the model, and we have 22 feet high for the actual building. Then we have 20 inches for the width, and then we're looking for the width of the other one. So I could start by setting up a ratio for just the height, and if I set that up, I would do the model on top. The model is 8 inches. The actual building is 22 inches, or 22 feet, I'm sorry. So when I set up a second ratio, I have to have the model, the width of the model on top, because I had the width of the height of the model on top here. I have to have the width of the model on top here, which was 20 inches, and that leaves us looking for the width of the building. So we have our butterfly wings, our little diagonals that we're going to do. And when we do that, we would have 22 times 20 for one diagonal. That equals 8x. And then when we evaluate 22 times 20, we find that it is 440 equals 8x. And then when we divide that number by 8, we find out that indeed it is 55 feet wide. Another example, Mrs. Hidalgo paid $30 for 4 students to visit an art museum. Find the cost for 20 students. Well, right here, we could set up a ratio for the amount of money and for the number of students. So this ratio would just be for the students. So when setting this up, I have the amount of money, $30, for the 4 students. Then it says find the cost for 20 students. So the 20 students has to be on the bottom, just like students was on the left side. And the cost is going to be on the top, just like it was on the left side. So now we set up our 2 ratios. And we're going to multiply 30 times 20 for one diagonal. The other would be 4x. And we know that 3 times 2 is 6. Add 2 zeros. And then we're going to divide that by 4. And your final answer would be $150 for 20 students. A utility worker is 5.5 or 5 5/10 feet tall and is casting a shadow 4 feet long. The 4 is missing there, but there's a 4 underneath that. At the same time, a nearby utility pole casts a shadow 20 feet long. Write and solve a proportion to find the height of the utility pole. So sometimes I like to draw models. So we have a utility worker. Here he is. And he is 5.5 feet tall. He's casting a shadow, and you can't see this back here, but this says 4 feet. He's casting a shadow that is 4 feet. So we have the height of 5.5 and a shadow of 4 feet. It begins to make it the side of a triangle there when you do it that way. A nearby utility pole casts a shadow. So we have a pole, and its shadow is 20 feet long. So when we draw it like this, we can tell that when setting up the ratio for the man, that we can set it up with his height to shadow. So if we do height to shadow, we have to do that for both of the ratios. So when we set that up, it would be 5.5 feet for his height and 4 feet for his shadow. Then for the pole, we do not know the height, but we know that the shadow is 20 feet. Now we can do our proportions. We would do 20 times 5 and 5/10, and that would get us 110. Set that equal to 4x. So now we just divide it by 4, and our final answer would be 27.5 feet tall. Let's just do one more. The wait time to ride a roller coaster is 20 minutes when 160 people are in line. At this rate, how long is the wait time when 220 people are in line? So what we have here is we have minutes and we have the number of people. So when we set up our ratios, we want to put minutes on top and the number of people on the bottom. So first it tells us that there are 20 minutes and 160 people. The second one, it says how long, so we're looking for the time on the second ratio, and there are 220 people in line, so that goes on the bottom. So now we know we are multiplying 220 times 20 on one side of the proportion, and then 160 times x on the other. So now we multiply 220 times 20, which gives us 4,400, and we're going to divide that by 160, and it's going to give us 27.5 minutes. Good luck in setting up proportions. I think, well, let me do one more with you. I'm going to skip here and there's some more I could do, but the video is getting a little bit long. But I do want to do one with geometry here. We do this a lot with shapes to find the missing side of a shape. This happens to be rectangles. You could actually set this up two different ways. I'll show you both ways, but you're going to get the same answer. Okay, so we're looking for side x over here. So I could take the bigger one and set up a ratio of small side to long side, 44 to 99. So when I do the next one, I want to do short side to long side, and that would be x over 45. That, if you prefer, you could actually set it up with short side of the, you could do large triangle, short side, which is 44, over smaller triangle, short side, and then you would do long side of the long triangle and then 45 on this one. Now that's a little more confusing, so it probably would be easier if you just kept your ratio with one of the shapes, took both of the numbers off one shape like we did the first time, but you will result in the same answer. Because if you look here, you have 44 times 45, which you would have over here, and then you have x. So both ways you have 44 times 45 and then 99x. And when you multiply your numbers and then divide by 99, you're going to get 20. So you can use this to find the missing side of shapes in geometry. Good luck with proportions.